this one. So hopefully there is no echo when using this. Yeah, I'm gonna stand up and I'm gonna make all the settings momentarily. Yeah, like somewhere here, roughly like I can tune the camera a bit. So here, you sure? Okay, so I'm gonna make just everything ready for streaming, like here. It's a bit confusing that it's working like this. Could be still a bit more. Oh yeah, because it's cropped. So that's why it is working like this. Ah, I got it. If it is like somewhere roughly here, but that would be like pretty much perfect. What do you think? Yeah. Gonna crop this like this and put this in a corner. And then we still need to take a look like, why is that this one is not displaying well? Uh, one more thing. So now he's making this. Was it? What was the way to? I want to duplicate that to my screen to make sure that it's. Yeah, this is the way to go. Okay, you wanna take a look? How is my streaming? So I'm gonna make it like this screen. How is it? I just need to make sure that I can make a drawings too. Still not willing to make any drawings. So what was the settings that make these drawings? Like these, and then was it like? Do I need to make this not the presentation mode, but this mode? Why? Still no willing to make any drawings. Why not? How is how it is displaying? Okay, but only thing missing is that I cannot make any drawings yet. My voice is okay and everything is okay. All right. And how did I look? Do I look strong? Very good. A little bit of. So should I do something for this chroma key? Oh, cropping is not correct. Or maybe you can adjust the cameras instead. Do you guys feel it? You feel it? You guys feel it? Excitement. Excitement. Getting started from academic season. What is better than that? Nothing. Sorry that is coming with this. But we need to do these settings to make sure that the online participants are okay. So we have a total of 190 students in a class, and you can do the math that there is no way that we have 190 students in this class, much less. So most of the participants are online. So that's why there's YouTube, and it's for your good too, because later, if there's something you don't understand in my lecture, you can go and take a look at the recordings and go back and forth as many times you want and make sure you have a full understanding. All right? So that's why there's all this hassle. But we want to be professional YouTube people, YouTubers, like you call it, because that's why the green screen and everything. So we want to make this in another level, really another level. Okay? So okay, so should I cut it like here down? But from my right. Okay, let's do it. Let's do it. So it's here. From your oh yeah, yeah, there. I see. So we do like this. We're gonna move like this. Not okay. Okay, we'll do it. Uh, no, no, no. How can I put this back? Undo. Yeah, and this here. Fantastic. So I'm gonna move this to another corner here. Okay. Yeah. So is it okay? Oh, still I need to crop that from the bottom. I mean from the top here. Okay, that's good enough. That's very good. Very good. Fantastic. By the way, the quality for online participants is a really, really good. The only thing, okay, fantastic. I see that every now and then the lightning condition is not perfect. Yeah, but everything else is perfect. Of course, of course. But let's get started. Okay, this is how we get started. This is our gang sign. We do this and we say respect. You know what is this? It's a three-dimensional coordinate system, and this is a positive rotation. So next time you see him in a corridor, you don't say, "Hey, Aki, how you doing?" But you say, "Respect, Aki, how you doing?" Can we do that? Can you be like that? Then it means that, okay, we are in the same gang. What's the name of the gang? Mechanical engineering. Mechanical engineering. That's the toughest gang within the family of LUT. All right, we have a deal. And I do that for another reason too, because when I do the setting my YouTube, it takes always a little while to make everything correct, and then I do a little bit editing to my videos, and I take everything, this hassle in the beginning, I'm gonna cut it away, and I know when I show this sign, I know, okay, this is when it's getting started, so this is a real deal. Hey, good afternoon. My name is, sorry, good afternoon. My name is Aki Mikola. I'm gonna be your teacher in a class entitled Simulation of Mechatronic Machine. There's gonna be a lot of fun ahead of us, a lot of fun stuff, something that you're gonna be very, very happy to learn, something that you're gonna blow your mind. Why? Because we're gonna do something quite exciting, something that you have no prior experience, something that I feel you're gonna enjoy a lot. And this is all introducing, when I'm introducing you to the world of simulation. And that's what we're gonna do. As the title of the class is implying, this is all about the simulation of mechatronic machine. So now it's getting started. So lectures every Monday afternoon, getting started at 4:15. And as I mentioned in my email to you, you can follow me by coming this lecture room, or you can log yourself to YouTube channel. Take a look at the YouTube channel. There's a playlist, lectures 2024. That's how you can follow my lectures, and you can take a look at the recordings as well. All right. So let me introduce you. Let me take this off. Let me introduce you something that I learned from the students just a little while ago. The university is giving you two big deals. First of all, it's going to explain you that, or going to give you a little bit of different kind of thinking, a new mindset. And the new mindset you're going to learn when you're dealing with a very, very complicated matters, like what you're going to learn in this class. Another big package you can get from this university is networking. New kind of thinking and networking. A new kind of thinking gonna make you survive in whatever you're gonna hit in your life, whatever problems you're gonna face in your life to come. You can have this kind of like certain kind of thinking that helps you to solve the problems regardless of their size. Then this networking is something that you need to get to know your fellow students. And this I learned. This QR code I learned just when I get started in the lecture. So this takes you to the WhatsApp group. And this WhatsApp group is about all the students in this class, correct? Okay. Now, make, please consider to join in. This is going to be very handy to you because what's going to happen in this class, there's going to be a lot of in-class quizzes. I'm going to explain to you something that is theoretically extremely complicated. And then I'm asking, you guys understand this? And always, every single year, the answer is yes. Yes, no problem. And I'm, oh my God, these guys have a very big brains because I myself, I struggling big times to understand this. But then when we go to midterm exam, the big disappointment seems that you actually did not got this thing. So now what we do in this class, when I'm explaining something, I don't even ask, like, did you got it or not? I'm asking you a question. And this question is in a form of in-class quizzes. That's how we're going to communicate. Because in Finland, for some reason, this seems to be the only way to communicate with my students. You could, in theory, raise your hand and say, hey, Aki, I don't understand something. If you do so, if you raise your hand and say, hey, I don't get it this, can you please repeat it? Can you please explain this in another way? If you do that, I promise I'm going to give you the coffee coupon so you can get a coffee in a cafeteria right after this lecture or anytime you want. You got everything so far? Okay, very good. So these are the QR code. So let me introduce you the teachers of the class. So I'm going to be the one that is taking care of the lectures. So you're going to meet me every Monday, the same place, same time. And then you're going to meet the doctor, Suraj Jaiswal. So he's currently in US. He's actually working in NASA. So he's a real, NASA engineer. He's on his way back to Finland. And later this week, he's going to come into first to see you guys. I don't know how he's planning to handle it, but he's going to be back in Finland later this week. And then Mustafa. Mustafa is our strong guy. So these are the guys. Me, Sturats, you're going to meet him later, and Mustafa. Mustafa is back there. So any chance that you can step here and introduce, show your guns. Can you? Please. Okay, no guns. Okay, no guns. No guns today. But I can tell you, if there's a disagreement between you and Mustafa, just say, yes, Mustafa, you're right about that. Because he's so strong. So that's what you need to do. Okay? So that's a Mustafa's face. All right, what I need to get somebody volunteer here. I need to get the YouTube officer because the majority of the students are not physically here, but participating using this online connection. And I have only one computer with me, and I don't see the comments here. I don't see if there's anyone giving any comments to my YouTube channel. So if somebody's carrying a laptop or iPad or even the phone could be enough, checking what are the comments and telling me that, okay, now there's a comment from online participants that they're asking me this and that. Anyone volunteer to do so? This could be a fantastic asset to your CV. You can mention that YouTube officer, simulation of mechatronic machine 2024. Anyone? You guys need to have a computer to do so. Anyone willing to volunteer to do that? Every day, every day. Oh, not every day. Here's my YouTube officer. Thank you very much. I appreciate this. So just look yourself to YouTube channel. Take a look at what are the comments. And if there's any comments, anything, let me know. You just raise your hand and say, hey, now online participant is asking this and that. Okay? Thank you. Appreciate that. All right, so what's going to happen today? We get started by ground rules. This is something that you must understand. You have to understand what are the requirements to pass the course. Of course, I know the stories that I'm not here to pass the course because life and everything. Yes, but end of the day, you need to pass the course. You need to get the credits from this course. Otherwise, your life is not going to be good. You need to understand how you can make that to happen. This is something that if there's any doubts, anything that is unclear based on my explanation, raise your hand and say, hey, now definitely I need to know this. What about this? Bad news is this. As I say, 180 students, so there's a very little room for flexibility. So if you want to get the special treatment because of my mom's got this and that. We heard all these stories. Believe me, we heard all these stories like, why you need to get this special treatment. We would like to do that for you, but it's very hard because think about the amount of students and each of them asking special treatment, like, can I get an extension from the deadline? Can I get this and that? It's hard. It is hard. But if there's something serious, like really a good excuse, let us know in advance. Okay, I have like a surgery. I have a medical condition, this and that. I cannot do this in a timely manner. So can I get an extension? Yes, you can if you let us know in advance. If you after deadline you contacting us and say, yeah, I had a headache and everything, I couldn't deliver in a timely manner. No, we are not able to give you any slack. Sorry about that. All right. Ground rules. Introduction to simulation is going to be later than mathematics needed in a course, description of rigid bodies. So I'm going to spend first half of the class introducing you a big picture because I would like you to understand why it makes sense to participate this class. And then we're going to jump to something that is called kinematics. Kinematics is how we're describing rigid bodies. That's going to be something that it's already mathematics. So this class is quite a bit of mathematics. So those of you that are shy with matrix algebra, I'm going to give you a little bit of hints like, okay, go ahead and familiarize yourself the basic concept using this and that. Okay. And then there, by the way, guys, you all have an access to Moodle website. The course Moodle, that's very important. You might have noticed already that there's lecture notes available in the Moodle site. Print it. Keep it with you all the time. So whenever you have a free time, whatever you're writing in a bus, open it, read it. Because this class is something that there's no way, absolutely no way you can learn within a day or two. And I always, you think that, okay, I can take a relaxed attitude. I can relax a bit. And as soon as we are approaching the midterm exam, then I will make my effort. No, here is not going to work like that. You need to work continuously every week, every day, even better. That's how you slowly started to digest the matters that I'm about to explain to you. All right. But let's move on to ground rules. This is what's going to happen in the next period. So I'm not going to take a look at that. As mentioned, lectures on Monday, displays our YouTube channel. Tutorials, stay tuned. Dr. Suraj Jaiswal is going to introduce details momentarily to you via emails, I suppose, or our Moodle site. Tutorials, those are the ones that Mustafa and Dr. Suraj Jaiswal are responsible of. So there's going to be a total of 12 weeks, 7 guided modeling tasks, and then some weeks to make sure that you will get the help to complete your simulation work. And SimScape and Mevra software will be used in tutorials, mainly emphasizing the SimScape. Here it is. This is what you need to understand. These are how you're collecting points. And based on how many points you were able to collect during the course of the course, you can get the grading based on the grading table that is so in the lower left corner, excuse me, lower right corner of my slide. Okay, we have 3 different things that you can collect your points. 4 actually, but like 3 of them that are major ways to collect your points. Written exam. This is something that is classical way to pass the course. Written exam is not actually written exam, but it is 2 midterm exams that will be organized online. Each of them will be, you have gonna have 1 week time to complete it. You will have 2 attempts during this week time. And then the highest grade will be accounted. We're gonna compute the average from these midterm exams, and that's gonna be the part of the points that are related to written exam. Weekly homework, 30%. This is going to be something that we're going to get started today. Later, once I'm done with my lecture, I'm going to post the first weekly assignment. You do the weekly assignment, you submit it using the Moodle website, or actually, this is going to be more or less automated, so you need to just complete this in Moodle. You can collect the points. Simulation work, that is 30, uh, 5%, and then the bonus points, a total of 10 points. So you could, in theory, score 110% out of the 100. We still aren't able to give you 6 out of 5 from this class. So maximum is going to be 5 out of 5, which is like extremely good. If you score 3 out of 5, that is a fantastic already. But this is how you're collecting points. Now you see this grading scale. So if you're just doing one of these items, but you do it really well, let's say you do the written exam and in-class quizzes, you can pass the course. You can get the 1. You're off the hook. Then you can go to another class and so on and so forth. So if you do, let's say, weekly homework really well, written exam really well, and in-class quizzes, you could easily score 70% of the points. You're going to get 3 out of 5, which is fantastic, extremely good. But it becomes to be increasingly harder if you want to score 5 out of 5. But theoretically possible. Okay. No previous knowledge needed, but we do need something. We can do attitude. You can do it. You can make it happen. You're selected among a large number of candidates, so I trust you can make it happen. It comes with the pain, physical pain. It's going to hurt a little bit, not too much, a little bit, but everything that comes without the pain is having no value at all. So this is, you need to work a little bit, and then you're going to give a credit to yourself. Oh my God, I was able to pass this hardest course ever, because this course actually has developed a reputation of being difficult. That is a little difficult. So, okay, so that's what we're gonna do. Written exam, pretty much what I explained. So there are 2 midterm exams. We get back to the details, and I'm gonna give you the training system prior to midterm exam. Okay, weekly homework. 9 weeks, getting started today, and the deadline is gonna be next week. So you have more than a week time to complete these weekly homework. Something that really comes with a big benefit. The big benefit is this: so if you do your weekly homework, then your midterm exam is a boilerplate. It's not going to be too difficult. So it's kind of like tackle 2 items if you decided to go with a weekly homework. You will get something that makes you well trained to midterm exam, and you will get the points from this weekly homework as well. Simulation assignment, it's going to be something we're going to discuss a bit later. It's going to be something that each of you need to do individually. And it's going to be given away. It's going to be announced in week 44. So not right now, but a little later. All right. In-class quizzes, a total of 24 points. So it's going to be this week getting started, and it's going to be from next period too. And yeah, so we're going to use this Socrative. So be ready, because soon I'm going to ask my first in-class quiz. So you really need to look into this system, the Socrative system. You need to memorize your student ID number, because this is the way you log in. And when I'm telling my questions with the multiple choices, you need to select the one that you feel is the correct answer. Use WhatsApp. If you're 100% sure that you absolutely know the correct answer, it's okay to share that with the other students. And I recommend you to discuss. If you know that I know this, I know the right answer for sure, it's okay to go around this lecture room and telling that for each of the students here. But you need to be sure that you really know the correct answer. Because if your fellow students are voting incorrectly because of you, you're not going to be very popular anymore. So that's something that you need to go easy with. Okay? All right. Here it goes. So this is how the Socrative look like. LUT is the name of the room. Not very complicated to memorize. LUT, right? So pretty simple. And you need to put your student number to log in. That's how we're monitoring your performance, whether or not you're able to identify the correct option out of the many. Okay? All right. So how everything feels so far? Clear? All clear. No comments? No questions? Not yet. Very good. Very good. Okay. Everything that I'm going to ask in midterm exam, simulation assignment, so on and so forth, all the material is going to be available either in these lectures, guided tutorials, or the material available in a Moodle database. This course is not about literature review. You can, if you want, you can go out there and make a literature review in a university library and Google, I'm not Google, but searching about additional supplementary material that is related to this subject matter. I don't recommend you to do so because there is, you know, a lot of literature in this subject matter, but many of them are not easy to digest. So why don't you stick with the material that is available in the Moodle database? That will save your time and energy, and it's somewhat, I'm not saying that it's easy to understand, but let's say that it's more understandable than many of the other material available right there, out there. So there's a rich literature about subject matter, but go easy with that. Of course, you can do whatever you want because your guys are adults and strong and everything, so you know how it goes. Okay. So there is these lecture notes, the ones that I'm saying handouts. All the slides that I'm introducing you during the lecture will be available right after lecture in our Moodle database. So focus on listen to me. Don't write. I mean, you can write some notes too if you want, but I'm not expecting you to copy paste what I have in my slides. You don't need it because you have the recordings afterwards, so you can go back and forth, like I mentioned, as many times you want. So lectures and tutorials, weekly homework assignments, everything is available there. All right, we do have a pre-recorded material that I'm hoping you guys are familiarizing yourself prior to lectures. And this material is called Temeko. Here is a very lengthy, complicated web address that takes you to this material. You can just Google the Temeko on YouTube, select the course, which is Simulation of Mechatronic Machine. There's a 3 playlists. Select the one that is entitled based on this course. Start looking the material. These lectures are 2 to 5 minutes in length, but they are somewhat easy to follow. Make sure that you're following this because this is a somewhat great supplementary material that helps you to understand what this course is about. Okay? Guidelines. Trust yourself. It's going to be fine. Like I say, it comes with a little bit of pain, physical pain, but at the end of the day, it's going to be fine. Trust me. If there's any serious difficulties, I'm here to help you. I'm playing actually in the same team that you do. So we are not, I mean, that we're looking face to face. It's almost like I'm one team and you are another team. No, it's not like that. I'm here to help you. You guys passing the course is going to make me smile, going to make me happy, going to be so proud of you because this is something that you need to make sure you will give credit to yourself. Another thing I mentioned, you need to make sure you're following the lectures and material every single week. Don't trust that you can digest this in a fraction of the day or something. That's not going to happen. Absolutely not possible to do it because this story is long. So you need to get started from the beginning. If you jump in the middle, it's going to be not possible. Also, something that is going to be very important you to understand that this important level of difficulty is progressively increasing. We're going to discuss something that today that you're, oh my God, this Aki is ridiculous guy. I learned this already in a kindergarten. This is super, super simple. And then okay, because this is so simple, I don't need to follow the lectures anymore. That's okay. I'm going to be fine. You skip 2 lectures and then you come back. And it's like, what happened? What happened? What is this? You call this math? I have never seen this before. So don't follow me every single week. Okay. Do exercises by yourself because this is the way, like I say, gives you the training for midterm exam. Highly recommend it. Please use a symbolic math software. Whatever is a symbolic math software you want to play with, My personal preference is a Maple, but you can use a MATLAB, symbolic MATLAB, whatever you want. But this course is about matrix algebra. You know, the matrix algebra is something that you can easily make a mistake, simple mistake. When you do the simple mistake, your answer is not correct. That's why it makes sense to use a symbolic math tool. That's what we use in our team daily basis. We don't really compute much using pen and paper, but the symbolic math tool. All clear. You guys ready for moving on? Okay. Do you have a can-do attitude? Yes. So next time when I'm asking you, like, do you have a can-do attitude? Yes, I'm feeling strong, stronger than Mustafa. What about that? Is that okay? Okay, let's move on. If you know how to pass the course, which out of the many options is the correct one? How can someone pass this course? Through networking, because the network, like I mentioned, is a part of the university deal. You party, you're spending a good time, and you will pass the course like semi-automatically, fully automatically, using ChatGPT, because ChatGPT can solve every single problem in the planet. So that's the second option. By putting the effort, keeping up with the lectures and material every week, daily, even better. Just take it easy, because Augie is a layback guy, and he would probably let me pass because of the flexibility. I have good excuses, cat and stuff. I'm gonna go and later explain it, so it's gonna be fine. Which out of the many options is correct? I don't want to hear that. You need to you need to lock in yourself to the circuit and vote it if you really think it is C. If you think it is C, okay, guys, take your phone, log into Socrative, and do it. You guys, Team Finland in the back, you guys able to log in already? Okay, good. Very good. Guess how I know that it's Team Finland in the back? Because Team Finland is always in the back. There is always it's a rule of thumb. That would be, by the way, a big surprise if Team Finland would be sitting here in the front and other teams would be in the back. I don't think it's never going to happen, but it would be a big surprise to see something like that to happen. All right, so take your time, and I'm going to momentarily move on. We're going to take a look at the correct answer. Are you guys able to copy the Socrative, put LUT as a room name and your student number as the way log in? You guys ready? You are all ready? Keep on going. I'm going to take a look how we're doing just to see how many students we have here. Okay, so we have 72 answers so far, so I'm expecting more. I don't know how many participants we have in online. Okay, so we have currently 79 participants online, and then you guys. Okay. Okay, but we got a lot of comments here in the chat. Okay, student ID not working. Okay, some of them are having to hard time to locking. I'm gonna take a look at these comments a bit later, but now I'm gonna take myself back here. I'm gonna move on. Next, short introduction. Why this course makes sense you to take? Why this is a mandatory subject matter? Not, I mean that because of the new way of thinking. Yes, but bit more concrete than that. So what is it really that you can learn from this class? That I'm gonna explain to you next. Then we're gonna move on to math, and then get started with the real deal. Okay, you guys ready? Introduction is this. Okay, what's the objective of the course? What simulation is about? What the heck is this simulation thing? And I'm quite convinced that none of you have really touched the simulation the level you're gonna touch it in this course, because most of the bachelor level courses is all about basic knowledge. You might have all the knowledge needed in math perspectives and physics perspective, in perspective of dynamics, but this is a little different. This is more pleasant. Now let me tell you why. because the most hated subject matter in bachelor level studies is what? Dynamics. If you make a list of courses that the students hate the most, what number one is the dynamics. Then comes nothing, because there is such a big gap. Then nothing, and finally, like structural strength, stuff like that, that people don't like it so much. But clearly, the number one is dynamics. Why? It's really heavily hated because dynamics, as it is being told to you before, is all about trying to create the relations that are not obvious. Creating something like equation of motion is a big pain. Here, we are not going to do that because we're going to use the computers to solve the equations of motion. And we are able to create the equations of motion automatically. I mean, with certain steps, and you need to work with. And once you work with, you can get the equations of motion. So it's much more pleasant than anything else so far because it's systematic. And systematic is something that engineers will love it, right? So forget about these relations. Forget about complicated relations, this and that. Is all gone. So we're going to just follow the certain steps. Once following these certain steps, we're going to get the equation of motion automatically. What next? Then we say, computer, solve it for me. Simple like that. Okay, that's the nutshell of the course. More details needed before you can pass this course. Okay. All right. How you build the simulation models? What are the advantages? Why it makes sense to learn this? Okay, I want you to understand that the computer simulation comes with a big promise. There's a very significant potential related to that in many different perspectives. So we're going to look at that. We're going to look at the theory because you guys are master level students. But master level students is not enough to be able to use a commercial software. Let's say finite element software, be able to click this and that, the model, this and that. That's not enough. Because as a master level student, you need to understand what's behind the hood, what's under the hood, how it actually works, what's the principle behind. Because this is the only way that you can ensure that you are not misusing the software. Okay. How is our YouTube officer doing? So there's somebody's complaining. What are the softwares we're going to use? Two softwares. Those are Simscape and Mevel. It's available in my one of the slides that I introduced you earlier. Okay. All right. Understanding the potential, understand the relationship between the computer simulation and reality, because it's not the same. There are differences. Where these differences are coming from, learning to use the simulation tools, that's what we're going to do. All right. So we're going to look at the things in a slightly different perspective than in other courses, because here we're going to model mechanical structures, but not just the mechanical structures. We can also look at how we can model the most commonly used actuators in a heavy machinery, and most commonly used actuators is hydraulics. And what we're going to do at the end of the day is we're combining the actuator models, mechanical models, and we are solving the structures as they are when you see them in the reality. I don't think we have a time to look at the control systems, but if we would, we could take a look at that too. And this would be a fantastic tool to make this kind of control engineering testing and analysis, software testing as well. But this is what we're going to do in this class. And what the simulation is about. It's just using the well-known laws of physics, nothing else. So if it is physics-based simulation, what we do in this class, it surprisingly needs to be based on physics. So how complicated is this? So we're going to use the equation that you see here. So we're going to use the Newton's second law, which is externally applied force is equal to inertial forces. That's what we're going to do. So mass multiplied by acceleration, that is inertial forces. And then external applied forces are F there. That's going to be our external applied forces. Those need to be in equilibrium to get the static dynamic equilibrium state. That's exactly what we're going to do. But a bit more than this, because this Newton's second law is going to be hard to introduce to computers, because computers, what they like a lot is vectors and matrices. That's where they are very good at. So instead of using the scalar quantities that like shown here, we're going to use the matrices. And once we use the matrices, the symbol equation turn out to be a big mess like this. Oh my God, this is horrible. So there's no way to survive. We're all going to die. No, we are not going to die. So it's going to be okay. This is the same equation we looked a little while ago. External applied force is equal to inertial forces, but explain it in a way that the computers can understand that. Because the computers are very good in matrix algebra. This is how it looks. You're going to be surprised. At the end of the course, you're going to be able to understand what are these weird symbols, what they are standing for, and you will be able to create the equation of motion regardless of the complexity of the system you're dealing with. So that's a big promise, but that's what's going to happen. But like you see here, so there's a lot of partial operation. There's a partial this, partial that. Yes, that's what this course is quite much about. You need to learn to deal with the partial operation. And that's why another good reason to use this symbolic math tool. So use it. It's okay to use it. All right, then actuator models, they look equally bad. So they are the ones that are located in the right side of the slide, equally bad. All right, what the simulation is about. So this is actually like accelerated learning process. So we can learn faster. Now, some people are saying that if you do simulation, you don't need to think. That's wrong. That's not how it goes. It gives you the tools to learn faster. And there is something that is called simulation disease. It's a very severe medical condition. No medication available. The simulation disease is something that you stop thinking. You're solving everything by using very, very complicated simulation models. Simulation is not about that. It's a tool to help you to make better thinking. The thinking is still needed. Okay? So don't forget about something that is called common sense. Now, here in this university, we don't even have the common sense. No, but we do have an engineering sense. Don't forget about the engineering sense because you still need it. Okay, makes sense. All right, so there are, this guy. I'm not going to take a look at this one, but there's a lot of different kind of commercial software out there. Each of them are working in the same, based on the same principle. This principle is what we learn here. So then it makes it easy you to move from one software to another because you understand how this is built on, what is the principle behind. So that's why this course is more than using Simscape and learning to click right kind of the icons, not understanding what you're actually doing, but more about understanding what you're doing and using this engineering sense while doing so. Okay, so these are the softwares available. Something extremely important. This is what I like a lot. Simulation, many people think, okay, this is I don't need it because it's a fraction of the product processes in a companies. Company product processes are listed here. And you see that, how things getting started is based on product development and like this says design and development. A simulation is only used there. So this is the only place you can use a simulation. So this is a very small fraction of the company turnover because this is typically, say, even from the large companies, it could be, say, 3 to 10% of the company turnover. So it's not a major deal. That is correct. You can use a simulation in product development. But what I would like you to understand in this course is that you can use it in other product processes as well, as we're going to discuss later once you understand the concept behind. It can be used even during the operation. It can be used in many, many different applications, but not just product development. But yes, it is true that our home is from product development. Okay, right. So that's what I would like you to know. These are the examples, where the simulation is being used. This is a biomechanical simulation where we wanted to analyze what kind of the exercise makes bone to be stronger. Very good example what simulation is capable to do for you. Because what we're really doing in this case, when you see this guy is walking and sitting, is we're measuring tibia. Tibia is a bone located here. How are the strains and stresses during this simple exercise? You could, in theory, do this in a real life too. What you need to do if you want to do this in a real life, you need to take a big knife, make a cut here, take a grinder to take all the slash away, attach the strain gauge to your tibia bone, put all the slash back, take off a lot of painkillers, and walk. Which one you prefer, that or simulation? Yeah, me too. Because do this kind of the biomechanical exercise, you need to get the permission from ethical committee. And if you can make a proposal like, I'm going to take a big knife and the painkillers, they're not going to like. They're going to, oh my God, this guy is crazy. This makes no sense. Simulation can give you the quantities that otherwise would be impossible. It's very, very difficult to get. That's the power of the simulation. So we can get something that otherwise hard to get. So this is the same guy doing the battling thing. So different kind of exercises. And why we do this? Seriously, because we wanted to know how the strain and strain rates in both the bone structure. Because medical doctors, animal tests demonstrated that this is what tells you what makes the bone to be stronger. Now we can make a tailor-made exercises to make bone to be stronger, and that's the way to make it happen. So simulation based. So this is a real-time simulation model. The one you can see when you step out from this lecture room, take a right, and go to this place that is called Sim Studio. Go ahead and play so you can know what are the real-time simulators, how they feels like, and so on and so forth. This particular model is not there, but there are 3 different models. There's tower crane, forklift, and block crane. Go ahead and play. Highly recommended you go and play. Okay, so these are the real-time simulation model. And of course, we can touch something that is very, very hot topic at the moment, which is how is it artificial intelligence? How we can make a use of artificial intelligence. And that's just a simple exercise where we're using artificial intelligence to control something that is called inverted pendulum. So this is a sticks, put it in upright position like this. And then you have this opportunity to move the place, this platform here. You want to keep this in upright position. This can be conducted using artificial intelligence using 2 different approaches. You can either learn the dynamics. This is method that is called reinforced learning. There's a lot of subroutines behind that, but this is a method that needs a lot of data, a lot of it. This one here is based on reinforced learning. You see that this is a very special case because this is an upright pendulum that consists of 4 different bodies. So it's not a single body like this. I can easily keep this in a balancing point like myself, like no problem at all. Then if I could put another stick here, it becomes to be harder. I can still make it happen. If you put the 3 sticks, still I can make it happen. No problem. You cannot, but I can. So it's going to be not so complicated. So like this, if you put 4 of them, even I cannot. Okay. Human, I think it can make only 1 stick to be upright position. Why this was so important? Because amount of cases needed to make the artificial intelligence to understand the dynamics behind was enormous. So it needs a total of 1 billion analyses. Okay, I have an accent, so you might not recognize when I'm saying billion. So I'm not saying million, but billion. You got the difference. Billion. So that's a lot. So that's the amount of data needed in many of the artificial intelligence cases. So that's something we're going to discuss later during the course, not today, not this period, but later. Then another case is something that is based on faster than real-time simulation. So it works like this. So if this is your time, the time is running with a constant speed. What we do in a real-time simulation is that we typically compare it much faster than real time. So we're going like this point, and then we wait. And what is it we're waiting? We're waiting until the time hits to the same spot. And this is how we synchronize in the computing. Once the time comes to the same spot, then we go again, like this. So this is how the real-time simulation works. So it's synchronized to real time. Think about this. What if we do not synchronize? So we're computing faster than real time. The time is going like this, but this going much faster, like here. What is this? Future. This is future. Now, if you have a lot of computing power like here, you can have a multiple motion scenarios. Each of them are projected to future. And then there's an algorithm, AI-based algorithm that is selecting the most desired one. So that's very, very fantastic. This is a really promising technology that you need to get the simulation model to do it. You guys know this best movie ever, Terminator. Terminator must be based on this. You think? Me too. I'm thinking that this is using this technology. Terminator is a documentary, isn't it? Is not? Ah, okay. I thought that it is. Okay. All right, guys. All right, so here's another case. This is a reinforcement learning excavator. So this is a model that is one of those physics-based models. So it's moving the dirt from the ground that is modeled using particles. And then the excavator itself is having the hydraulic components, it having the mechanical components, of course, but there's no human. This is operated by artificial intelligence. Another big area, of course, what there's a big desire from heavy manufacturers is to use autonomous solutions as much as possible. This may be part of the solution. It's not the full picture, but it's a part of it. All right. One more slide about this, what this course is about. This needs a little bit of explanation. So I have here a trend that shows how is the stock market that is called S&P 500. There's a stock market in US and how it's been evolving during the course of the years. So it's getting started in 1987 and ended 2020, 23. And what I would like you to learn from this is that things are changing radically, and how they are changing is explained by this graph here. Is showing that how is the value that is related to something physical, something concrete that you can touch, like this stick, how that is increasingly being replaced by business that is based on data and knowledge. Software is a good example. When I showed this figure to people in the mechanical engineering, they're like, oh my God, this is really, really bad. So we have no hope, right? No, we have a lot of hope because this data and knowledge is all about what you guys have. So of course you have this ability to make a hardware, to make a real product, like concrete stuff, like stick or whatever mechanism you're dealing with. But in addition to that, you have this ability to make something additional because all the skills you're going to learn in your master level studies. Skills is data and knowledge. All right, so that's what I would like to explain to you. Let me take a look. You want to have a break? Okay, you need a break. I need a break. Many of you are saying, okay, let's take a look at this. And then we're going to move on to something that is kinematics of rigid bodies. Okay, make sense? All right, so summary. If you use a real-time simulation, this is a fantastic tool because then you can use data in a way of like gamification to make sure you have a better understanding what the customer's wants and needs. This is something that is important. So it can be used to introduce new services based on data and knowledge, like we discussed. It can use in a conventional product development to reduce the time spent in the product development. And it, of course, improves the quality of products, makes the products to be more reliable. That's what the simulation is capable of. Okay, so you're going to be with me. So you're buying this? Okay, so you say deal. You're going to come to next lecture 2, which is getting started right after the break. Okay? Okay, so guys, what do you say? How much time you need to recover? 15. Okay, what about shorter? Because I'm in my bike and I noticed that it's raining soon, so I need to get back my home, not to be completely wet. So how much? How much? 10 minutes. Okay, 10 is a good compromise. So 10 minutes and come back. 10 minutes. The online participants, so it's going to be a break of 10 minutes. So we get started 5:15. 5:15. Okay. Hold on. I'm gonna make the camera to be something that they don't see you, and I'm gonna also Okay, guys, so we're getting started in a minute, 1 minute, and then we're gonna go again. 1 minute. Okay, guys, so where is that you're originally from? What country? Yeah, Nepal. Okay, so we have a team Nepal here. What about you? Pakistan. So we have a team Bangladesh. So we have a team Bangladesh. Okay, what about you guys? We're Bang Pakistan, Bangladesh, Pakistan. So we have a team Pakistan here in the front row. Okay, you from India. Okay, we have India here too. So team India in a front row. Very good, very good. I'm not surprised. I'm not surprised. Also not surprised that Team Finland is sitting in the back or online. Okay, all right. So what do you guys think? So let's take a look at the in-class quiz. How is going to be the success rate today? What percentage? It's going to be 100? Less than 100? Yeah, yeah, yeah. We'll see. We're going to take a look at that momentarily. But remember, this already is making an impact to your life. So this is how things getting started. Because if you vote correctly, you're going to get first points. All right? You still need more points to go, but this is how things getting started. Look at how easy it is. So it's not you just sit here, relax. It's gonna be fine. Okay. So we have 117 students here answered already. Okay, so let's take a look. So I'm expecting success rate 105%, 110%. Okay. Oh my God, it was close, close. 97%. Okay, 2% is voting for parties and networking is the way to go past the course. No, that's not true. 1% is making major mistake. Two mistakes. First of all, thinking that there is a way to pass this course by taking this layback attitude. I mean, take it easy way. And that's also because Aki is a layback guy. I'm not. I'm not. So this is twice incorrect. So I'm uptight guy. So you don't want to, yeah, I mean, you want to stay away from me as much as you can. Okay. All right. So that's how it goes. So the next one is going to be harder. So it's going to be a little bit harder. But we're going to take a look at that momentarily. I'm going to already put this visible to you. So once this becomes to be, um, once I introduce this to you, then you can start voting. So let me take this display away and put my window back. All right, so that's where we are at. You guys need to take a look at the proper view. Okay, mathematics needed in a course. That's going to be the next short stop. And as I say, short. So we are not going to spend too much time here because this course is not about mathematics. However, as you do need mathematics, and there may be some of the concept that you don't remember anymore, I recommend you to go and revisit or visit in a place that is called Khan's Academy. You know, the lecture note is categorized in sense that in a way that each of the matters explained. If you need to get the further information about the math behind, there's a there's a kind of link to the website for this Khan's Academy, and you can take a look how it goes. Like if you don't remember the chain rule of differentiation anymore, fine, that's okay. Go and take a look at that particular mathematical subject matter from Khan's Academy. You're gonna be fine. Okay, so Khan's Academy is the way we go. Also, you need to get to know the mathematical terms because this class is all in English, and because I have an accent, so some of them may not be clear. But again, remember, you have all the time this magic power. Raise your hand and say, Aki, I don't understand. You can make your life easier. Your fellow student has no idea. Absolutely, completely off. No idea. If you say, I don't understand, people will be relieved. Finally, somebody is saying the obvious. No one else understand anything here. Okay. Plus, you can get the coffee. So it comes with the two big benefits. All right. So let's get started from kinematics. So this is where the real course is getting started. So in this course, to model and analyze mechanical structures, we're using the method called multibody system dynamics. Multibody system dynamics, as the title implies, is a method that applies for a system consisting of multiple bodies. So it's a very powerful method as it is capable to create your equation of motion based on systematic approach. No serious thinking needed. And this is, by the way, the most obvious mistake that people do. So they started to make shortcuts as they're used to deal with the shortcuts and as they're used to deal with, something that you need to find a relation between this and that. This course, don't do it. Just follow the certain steps, certain procedures, and once you follow those in details, you're gonna get the equation of motion automatically. No thinking needed. Thinking, even though that I say that engineering sense is needed in this class, but when you're creating the equation of motion, it's all about systematic approaches, all about certain steps to take. And multi-body system dynamics is exactly that. So it is a way to solve the dynamics. As the title also implies, dynamics of system that consist of multiple bodies. All right. There's another very significant limitation that comes with the multi-body system dynamics. And that's the fact that in multi-body system dynamics, bodies need to be combined together via joints that later will be described mathematically using constraints. What are the different kind of joints? Revolute joint, prismatic joints, you have heard of them all. So this is like what you can see in a real life. So if you think about crankshaft mechanism, like the one that is in this example A, it consists of three moving bodies that are piston, connection rod, and a crankshaft. These three bodies are connected together via joints. Piston is connected to crown via translational joint. Piston is connected to connection rod by a revolute joint. Connection rod, another end of the connection rod is connected to crankshaft. What that means? So it means that there is this constraints, or let's say joints, eliminates the motion possibilities of the bodies. So let's see if you take, for example, the body in the middle, which is this connection rod. The connection rod, this cannot go as it wants. It has to be part of the mechanism, and it can only move in a certain way based on the how is a configuration of neighboring bodies. That's, by the way, what is a kinematics. And solving the kinematics is just solving the configuration of the system using the information that is hidden, that is joints, constraints. This class is all about rigid bodies. We could introduce mechanical flexibility within the multi-body system dynamics, and it's very, very often used technique. But this class is all about rigid bodies, which of course is something you don't find in real life, because regardless of the how stiff is your structure, is always flexible. Something like rigid bodies is only mathematical thing where we're making an assumption that the body deformation is insignificant in terms of dynamic performance. Okay. One more thing that is extremely important in equation, in a multi-body system dynamics, is that in a multi-body system dynamics, we make no assumption regarding the magnitude of rotation. Crankshaft connection rod here too is an example. Crankshaft can rotate as much as it wants. This is a major difference comparing what you have learned so far. Because you go and revisit in your lecture notes from Dynamic 1 or Dynamic 2 course, most typically, there is a major assumption that is related to magnitude of rotation. Because if, think about the pendulum here. If you think about the pendulum and you make an assumption that this rotation that the pendulum can experience is small, you can linearize the equation of motion. You can find analytical solution to solve the response of this pendulum. But if it is like this big, here to here, Okay, this is a nonlinear system. A nonlinear system, generally speaking, there is no analytical solution available. You just cannot solve this analytically. You need to solve this by first creating the equation of motion and then solving the equation of motion in forward of time. And then you will find out the response in time scale. Okay? Large rotation, bodies connected together via joints. That's the multi-body system. Examples are like biomechanical systems, like here, joints, neighboring bodies, joints, robotic systems, mechanisms, so on and so forth. So all that can be analyzed using this method. Okay, you cannot, I mean, if you deal with the simple statical examples like simply supported beam, this method is not very good. There are better methods to do that, way better methods. This is all about dynamics. Okay, now here I have two examples for you. Crankshaft mechanism and the one that is B, also connected, I mean, also consisting of number of bodies. Number of bodies in first example are connected together via joints, right? Second example, they are connected together via via spring elements, which is conceptually very different, very, very different. Only one of them is multi-body system. Which one? A, correct. Because again, multiple bodies connected together via joints. Second one is not, because this one is something that you cannot solve the kinematics. You cannot solve the position of, let's say, the lowest body of the system by knowing the position of the highest body of the system, because the connection is based on springs. A spring is a force element, so it's something that you need to deal with this force that are coming from the spring elements. It's conceptually very, very different. Whereas the another one is simple mechanism. So if you know, this by the way is a 1 degrees of freedom mechanism, meaning that if you know the position of the piston body or any other bodies, then you can compute the position and orientation of other bodies. Okay, so that's the multi-body system dynamics. That's what the multi-body dynamics is about. Clear, clear, clear. No hands up. Okay, all right. Which one is not a multi-body system? So this is So there is already a disagreement. But I see that some people are saying that is D, some people are saying C, some people are saying B. Okay, what are these systems? So this is a biomechanical system, robotic system, front suspension, and front suspension. Front suspension. Careful with that. Careful with that, because front suspension is a mechanism where the bodies are connected together via joints. And the final option is a cantilever. Excuse me, simply supported beam. Okay, you guys sure that is simply supported beam? You sure? Then put it in a chat. This, I mean, there's put it in this WhatsApp group. That please, each of you vote for D. If you're sure about this. If you have any doubts, don't put it. Okay. Okay. So we're gonna revisit this, but let me explain to you something else of it. All right. This multi-body system dynamics is a beautiful, beautiful method. By the way, this multi-body system dynamics is something that I've been studying pretty much all my life. I could change my middle name to be Multibody System Dynamics. So it could be Aki Multibody System Dynamics Nicola. How you like about that? That would be really, really good. Okay, still, because the method is not simple. This keep on surprising me. Every now and then I'm like, oh my God, this is how it actually goes. I have no understanding here. So that's why I'm saying that you two need to study this every single week, every day, even better. Okay, we learned what is a multi-body system. So the system is something that consists of multiple bodies that are connected together via joints. So now this is a like graphical representation of what this is about. So upper part of this is a umbrella, multi-body system, one multi-body system that consists of multiple bodies. If you take one body, let's say body 2 here, which is a like random body here, you look what the body actually is consisting of. So the body consisting of something that is called particles. Particles is a mathematical quantity that don't consider like how can I find particles? You can find particles, of course, in a real life, but here in this class, don't think about particles as something that you can, you know, think about what is their color or something. It's a mathematical quantity that helps us to build the bodies. Particle is very, very small. It's really, really small. It's so small that it's like you cannot even see it. Because it's so small, particle do not have a rotational degrees of freedom. You know that this body here, if this is a body, beam-like body, I can, in a two-dimensional space, which is a called planar space, I can translate it, I can rotate it, this body. But if I make one step forward from my body, if I look at the particles that makes this body, these particles are really, really tiny. They're like dots. How many dots? Infinite number of dots. There's a huge number of dots, so many that don't even think about it. It's a millions and billions and hundreds of billions, or I don't know. So it's a trillions of particles. So it's a really a lot of particles. And after that, when you put together these trillions of particles, that's how you're gonna make a body. But ingredient of the body is a particle. And because it's so small, it only have a location in space, two-dimensional or three-dimensional space. Only translation. Of course, the body can have a rotation, translation, that's all possible, but the particle cannot. Now, what we're going to do next is that we need to learn how to describe these points that makes the bodies with respect to reference coordinate system. So this is all about taking you to computational dynamics. But the first, we need to do computational kinematics. Kinematics is the art of defining particles and bodies, nothing else. So we just need to set the rules. Okay, so I want to define each of the particles that makes my body this particular way. And once you make your decision, rest that you need to do is that you just need to be consistent. You cannot change the kinematics any longer. So once you set your mind, that's it. As simple like that. So that's what the kinematics is all about. All right, so here's the deal. So here's the situation. So I have my body, planar body, called A. And this body I'm gonna put, I highlighted here, three particles, three, but in reality there is more, much more. And the challenge is this. You need to describe these three particles with respect to your reference coordinate system. My pen is not working today. I don't know why, but I cannot make any drawings here. I'm gonna give a, for some reason it's, okay, let me try this. Make a simple trial if it's gonna work like this. Oh, yeah, hold on guys. I need to do it like this. Now I know how to make it work well. Ah, it put me the first slide. I don't want to be there, but I want to be here. Okay, let me just see. Oh yeah, fantastic. Really, really fantastic. You will see this momentarily. Here it comes. Challenge is this. That's what we wanted to do. We wanted to describe these particles, three this time, but in reality, much more, with respect to this coordinate system. Okay, not too complicated because remember, this is just a point, nothing but the point. I don't need to care about the rotational degrees of freedom of any of these 3 points, particles. How can I make it happen? Well, it could be simple like this. I can just take a vector from the origin of my reference coordinate system. That's where it's getting started from the origin of this guy here. And it ends whatever this particle is located at. Okay, this is not very good. Why? Because if you look at how this one vector is consisting of, each of these vectors consist of two components. These components are a x, which is a projection of this vector with respect to global x coordinate axis, and another component that is with respect to y coordinate axis. The same for each of these three vectors. All right, so I can write for this one here to be such that it is RA3X, RA3Y. Okay, you see that this is not going to fly. This is not going to be a good way to go. Why not? Because now I have three particles that I'm showing here. It's not changing. Huh, it's not changing. It got stuck. Discard. Okay, you guys need to get familiar with this. Every time that I do this YouTube, it also comes with a certain times with the technical difficulties. But this time, I don't understand why it's saying that it's not. Okay, so maybe it's related to. I'm gonna do it in a way that I'm gonna show it like display capture, like this. So now it's supposed to be fine. And then, guys, just a second. Now we'll get back to you momentarily, like here. How is a YouTube officer? How it reads now? Yeah, it looks good. I can see it from my phone. All right, so I say that the problem is this. So now I have three vectors, each of them consisting of two components, RA3X, RA3Y. Sorry about my handwriting, it's not very clear. So now I have three particles, but I already need six components, three vectors. Each of the vectors has the two components. So it's a total of six components. How many I still need? Infinite, more, because remember there's a millions of billions of trillions of particles. Millions of trillions of particles multiplied by 2, this is not going to be computationally possible anymore. I cannot do this. I need to do something clever than this. Something more clever than that is, why don't we make a use of the fact that these particles cannot move with respect to each other? Why? Because this is a rigid body. If there's a rigid body, the particles cannot move with respect to each other. You agree? Like if I say, okay, what about this particle and this particle? Can they move like this direction? They cannot, because this is a rigid body. It's like made out of the highest, strongest ever steel material, so there's no way that they can move. Okay, so if that's the case, let's introduce something additional. Let's introduce something that is called body reference coordinate system. What is this? This is a additional coordinate system. So we started here. So this is our reference coordinate system. And then we have a body reference coordinate system that is attached to body. It means that if body translates, it will do the same. If body rotates, it's doing the same. So it's really rigidly attached to the body. So whatever body is doing, that body reference coordinate is doing exactly the same. So they cannot separate anymore. Fantastic, because now we're getting to be close to the solution that is kinematics. Because now, with respect to this coordinate system, each of the particles, let's say the particle location with respect to that coordinate system is what? Constant. Why? Because this is a rigid body. Fantastic. Only thing we need to do is that we need to create description of each of the particles first with respect to body reference coordinate system, and then convert that to be with respect to reference coordinate system, that is this guy here. And then the motion accomplished. I mean, the mission accomplished. What do you guys say? Uh-huh. I see from your face that it's no longer, yes, I can do it. I have can-do attitude. I'm strong on everything, so I'm stronger than Mustafa. And you're thinking, I'm not sure. Strong. Mustafa looks pretty strong. I don't know. Not sure anymore. But you're still with me. No hands up. Your fellow students has no idea. I can tell you. I can tell based on your face. All right. Let's move on. So what we're gonna do is that we're first describing each of the particles using the body reference coordinate system. This one here. And to make clear that this is body related description, I'm going to use U bar. Bar as a body reference coordinate system. Okay, so that's how it works. Now, of course, it's clear that this is the body rotation here. Excuse me, the body particle position with respect to body reference coordinate system is not simply adding this vector and this vector because they're in a different coordinate systems. So, like I say, first you need to map this one here to this coordinate system, and then you can add it up. Then you can add it up. How is that I can make this kind of complicated thing to happen? Here it is. I know you guys are terrified, like, oh my God, is it going to be this like all over? No, it's going to be worse, much worse. We're still warming up, okay? All right. So mission, what we wanted to do is this. I want to know how is this vector here, which is a vector u bar. So this is a vector that is described with respect to this coordinate system, how that is projected with respect to my reference coordinate system. So what I really need to know is I need to know this projection here based on this one, okay? And I need to know this projection here based on, well, the same story, the same vector. That's what I need to know. Once I figure that out, that's kinematics. And then what we're gonna do then is that we're gonna reuse the kinematics over, and over again. Okay? So let's make it happen. So let's compute it. Let's compute first this X projection, this one. How can I make it happen? I see that the body reference coordinate system in this planar case is rotated amount of theta with respect to my reference coordinate system, this one here. And the vector u bar is having the angle of alpha with respect to this body reference coordinate system. So if you add them up, this one here is then alpha plus theta. Okay. All right. So this is what you got. That's what I learned already when I was, I don't know, junior high school, million years back. So this is simple. So this is all about trigonometric functions. So I know this back and forth. This is not very complicated because obviously this projection, this X projection here is cosine this, because it's this one, cosine alpha plus theta multiplied by the length of vector u bar. That's what it is. This one here is the same, but this time of course, because this one here is a sine alpha plus theta multiplied by the length of the vector u bar. All right, then next, I will take a look at one of the math books where it is giving me a trigonometric function showing here. I don't care about details. I just take it and use it. Okay, I'm gonna take my math book, like this one, and then I'm gonna substitute this one here and this one here. Okay, no thinking needed. And I'm gonna get this equation. Getting close at the solution. Something that I need to know, something that I need to do is that I'm gonna use this X projection, which is this vector here projected to this body reference coordinate system. So this projection here along the x-axis is going to be, of course, the length of the vector u bar multiplied by cosine alpha, only alpha. Okay? This one here is going to be, of course, the length multiplied by sine alpha. And then I'm going to substitute this one to this equation. So it's going to be here, it's going to go there. Okay. This one is going to go here. And then this is going to go again here, getting the messy, but you're still with me. And then this is going to be one more time here. And what I'm going to get is this one here. Okay. So I'm going to get something like this. This looks very promising because now I'm going to have a mapping that converts my vector from body reference coordinate system to reference coordinate system. The mapping between the two coordinate systems. Okay, so I'm almost there. So this is what I got. But now I decided to do something. So I'm going to take this vector u bar and set that to be on vector like this. What is left is going to be 2 by 2 rotation matrix. This magic converter. So the magic converter that converts representation from body reference to global. Body reference to global. Body reference to global. This is 2 by 2 rotation matrix. Those of you that are into the mathematics, you might like to know that this is orthogonal matrix, meaning that if you're going to form vector based on this column and this column, they're going to be perpendicular with respect to each other. And they are, because they're representing x and y axis of body reference coordinate system. So perpendicular is meaning that it's having the 90 degrees angle between them. There's a unit in the length. Orthogonality condition doesn't need to be a unit in the length, but this is special because it's orthogonal and unit in the length coordinate system. Now look in your faces. You're still okay. Okay, so if you cannot find a way out from this lecture room, I can tell you that the door is located over there. But okay, this is still okay. But make sure you're following this every week because, like I say, this becomes to be progressively increasingly difficult. Progressively difficult. All right, so this is it. So this is our kinematics. This one here is called rotation matrix. It's a 2 by 2 matrix that converts vector u bar to be represented with body reference coordinate system. So entire kinematics is this. You need to take the translation of body reference coordinate system into account. Then you need to take the rotation of body reference coordinate system into account. This guy. Translation, this guy. And then this translation maps this vector u bar to body reference coordinate system. Mission accomplished. This is our kinematics. So we're going to make the kinematics based on body reference coordinate system over and over and over again. Okay, example. Okay, beam-like body, like this, like what I have here. The beam-like body has translated in a way that it's mentioned here. So it's at 2 units along the global x-axis, 1 unit along the global y-axis. All right? It's a rotated amount that is mentioned here. So it's a p divided by 2. So that's a 90 degrees. That's how much the body reference coordinates has rotated. Okay? Now, tell me where the one end or the free end of the beam-like body is located at. So this is a simple thing. So it's all about substitution. So we need to substitute what we learned in a little while to this equation, where this takes the translation into account, this takes the rotation into account, and the vector u bar tells me how far off is the particle we are interested in with respect to body reference coordinate system. Okay, so simple. This is going to be substituted here. Okay, b divided by 2 going to be substituted at the one we learned a little while ago, this 2 by 2 rotation matrix. And then comes the difficulty. It mentioned that the length of the body is a 1 unit. Of course, this is not scaled well. Okay, so I need to figure out, like, if I'm here, I need to travel to this end. How can I make it happen? Look where my body x coordinate axis is located. So it's located in pointing upwards. So I need to travel 1 unit this direction. That's where the 1 is coming from. I need to travel nothing to this direction, 0, this direction. That's where the 0 is coming from. The rest, you just do the math, you're going to be okay. This is your rotation matrix. This is your vector U bar. The final position is 2 by 2 units in a global x direction, 2 units in a global y direction. And of course, this picture is not in scale. Okay, clear? Yes, sir. Yes. Okay, this is a really good question. So it goes like this. Here's my beam-like body, let's say in initial configuration. This is my x-axis, y-axis in my body reference coordinate system. My body is having this configuration. X is pointing upwards, y is pointing left. Now, R takes me here, so I'm here now. And now my world is this coordinate system. How far I need to move to this direction to reach this point? 1 unit. How far I need to move to this direction to reach this point? Don't move anymore because you're already in your final destination. So no motion in this y direction, but you need to move 1 unit to x direction. That's where it's coming from. Makes sense? Makes sense. You sure? You're absolutely sure about this? What about online participants? Oh, by the way, the one thing that I noticed during the break was that there's somebody was asking me to repeat this, and I did this already. So somebody was asking about the software, and I said incorrectly because software, this question was about symbolic math software. So the other software that I mentioned was Mabel. Mabel. Don't use this. I use this. It's a big pain. Not easy to use. Okay, this is my biased opinion. You can use whatever you like. Okay, here we are. Another example. Then we're going to take a look at the in-class quiz. Here's another example. Okay, so I have here x-axis pointing this direction, y-axis pointing this direction in my body reference coordinate system. Again, the same story. What is given to you is a translation. So this is very clear matter of a substitution. So I'm going to take this 1 and 1, move it here. Then amount of rotation is also given here. There's a 3 multiplied by pi divided by 4. So it's gonna take it here. The only thing left. What about the vector u bar? How can I find my way to this end when I'm located here and my life and my world is all about the body reference coordinate system? How much I need to move to this x direction? So the length at this time is a 2. So I need to move minus direction. Correct. How much minus? Minus 1. Correct. How much I need to move this direction? 0. That's where the 0 is coming from. You do the math, and that's how it is. Makes sense? Makes sense. Do you have a can-do attitude? Yes. Do you feel strong? Yes. Very good. Very good. How is the success rate in class quiz? 110%. 100%. Okay, let's take a look. Ready for that? If you guys gonna score 100%, I'm gonna I don't know what I'm gonna do. Cry. Maybe I'm gonna cry. I don't know. I'm gonna call rector like immediately. Hey rector, take a look at me. So I'm the best teacher ever. So my students are capable to score 100%. Yes, sir. Minus one. Minus one. Okay. So here's my being my body. My x-axis in my body reference coordinate system is pointing this direction. My y-axis is pointing perpendicular direction. And now I'm here. So I'm here. This is where I am. And I need to move this end with respect to this coordinate system. So forget about everything about reference coordinate system. So it's all about body coordinate system. So you need to move along this axis here. And this is a minus direction because the positive direction is pointing this direction. So this is minus one. And I should not go anywhere this direction. That's where the zero is coming from. You got it? Good. All right. What about this? Here, this 130. So it's what? So it's nothing. So what happened? Okay, so it's back. So let me see how this is displayed for online participants. It's displaying well. So yeah, somebody's actually proposing that I should actually change my middle name. I should to be Multibody. All right, success rate here today is how much? 100%. 100. You sure? Because you guys say that it is. You were saying front suspension. No, you did not. You said simply supported beam. Okay. So simply support. So you put it in your WhatsApp team that please each of you vote D. You did not. You should. You should. Because the right answer is D. D. Okay, let me explain. Biomechanical system like me. Bodies, multiple bodies connected together via joints. Actuators like here, big muscles, big ones. And then robotic system same, but more mechanical joints, like not biomechanical system. Front suspension. Front suspension, those of you that are in a car, there are mechanisms. There are springs, but there is mechanisms. It's a mechanism. That's what the front suspension, like a bicycle suspension system, rear suspension system is a mechanism. So that's why that too is a multi-body system. Simply supported beam is not. Okay, guys, let's go home and see you on Monday, next week, Monday. Same place, same time. Take it easy. Have fun. Okay, let me just a second. I'm gonna close the camera so that others cannot see you, and I'm gonna close the recording too. Um, video capture device. Okay, and then just a second. I'm gonna